All right, we were briefly disconnected there, but we'll continue with this demonstration where we're at. So we displayed the data set that we're using. And then first put the data in the data lake. So share my screen. We'll go to data engineering. And this assumes I last left off, assuming that we've already created a workspace and a OneLake data lake item. So if you go to workspace, you will have this workspace with a bunch of different items in it. We'll navigate to our lakehouse. So we named it DE, first name, last name, ODSA. Okay, so we have our tables and files in the data lake. You see that I've uploaded the FatCoin history ETH CSV file. You can do that through get data and then uploading files. So Fabric, data science, and Azure machine learning, they prefer to have data already within a table in OneLake, especially Microsoft Data Fabric. So what you can do is click the file and load into table, a new table. And that created the FatCoin history ETH table. Now, before you create a model, oftentimes you want to transform the data or clean it in a way that you need it for a model, for modeling purposes. So we also do that in here in this example. For this example, we're going to use a Spark notebook to do that. So we have a Spark notebook called Clean FatCoin History ETH. So now that you already have data loaded into the data lake table, OneLake table, what you can do is now query that table using T-SQL notebook. You can select that FatCoin ETH. Make sure you have the correct lake house selected. It's this one with my first, last name, and ODSA. You see what I want to do here. This isn't the workbook that I was working out of. Okay, so go to a different notebook. It's notebook 2 instead. We'll use a T-SQL. Actually, we end up using PySpark. You could use T-SQL to use query-like expressions to clean the data and then load it into a data lake table. We're going to choose PySpark because it has this SQL library where you can do SQL type operations on it also. We'll go ahead and get this Spark instance running by clicking run all. You see what we're doing is that we're going to query from this data lake and then this table within the data lake. So the workspace name, or that's actually the data lake, the lakehouse name, and then the table, the Delta table inside of it. So what you can see when you run that successfully, you can see the results within that table. Then one thing we want to do in this is to create a time column as a timestamp. So the model that we're going to create is a forecasting model in this example. And what you need is a timestamp variable here that's equally spaced. So you see, once we convert it from the Unix time, you have 12:17 going from 2 o'clock in the afternoon over even until 12:18, the early hours of 12:18. And then once we have that data frame created, we can write that back to a delta table with, I put a model at the beginning of it so that we know it's a table that we're going to use for modeling. All right, so the next step is to go to your Fabric Data Science. So we'll go ahead and go there. And you want to create a new ML model. We'll click this. Then it'll just ask for the name. I've already created one. I went through the steps, the auto of ML. Let's see. This TS coin history ETH ODSA model, but we'll go ahead and create this model from the start. So ML model, let's give it a new name, model fact history ETH prediction. We're using a machine learning model to predict future observations or future times into the future. So we're going to, with AutoML, accidentally click the wrong button there. Go back. Start with AutoML. So choose data source with favors, like I say, it's very favors data out of OneLake Data Hub. We will choose which data lake we want to use. With our data lake and click next. Then we'll choose data. We'll choose that table that we inserted clean data into. Can't see the whole name, but we'll go ahead and click on that to load preview and make sure it's the one that we want. Could also expand some of these values. That will be the one that we want. Generate the preview. We'll allow that to happen just to make sure it is. Yep, it's the one that we created with the new time column. Click next. We'll do two examples in this one. We'll do a regression and a forecasting model. So forecasting, quick prototype, we'll run experiments to see which model is the best and then help you select that. Do quick model. We want to predict the future rate, which is the price of Ethereum. Choose your time column that we have as a timestamp, which is our time column. Forecast horizon and frequency. So I choose hour. And then let's just do the next. See if it'll allow us to do the next 12 hours. Then you could redefine the types or do some extra AutoML help prepare the data for you. Okay. But really we want to train multiple models at the same time. Use Pandas data frame. Create a new AutoML notebook. Call this ETH predict 20 hours or 12 hours. You can name it whatever you want. Always try to name it something descriptive. Here's the experiment name. That's how it will log that with AutoML, or not AutoML, but with the other machine learning library that we're using. Okay, so we'll go ahead and create. Can't think of the name of it off the top of my head. We'll see it in a second in our notebook. So you log experiments and model with the libraries. So MLflow is what the name of what I was thinking of. You can log your experiments and models with that. So we'll just go ahead and run this from the top. It doesn't always work perfectly. Go ahead and take a look. So what it does, it generates this code, reads the data from that model table that you built, displays the results, creates, and then it's the modeling steps, so featureization, test and train, tracks your experiments. That'll be important for us to take a look at fit and decide which model we want to use. And it can configure some of the AutoML settings and training the model, and then save the final machine learning model within MLflow. And that will be important because that's how we'll eventually create REST API connection out of it. And then it'll save the predictions in a Delta table. So this one has an error, but I have another notebook that I've run. We'll go ahead and take a look at that. So this is the same thing. I did a forecast on this. I had to clean it up just a little bit. Oop, that's actually not the right one. This one should be the right one. It's the same thing, same data, cleaned up version of the code. I'll share with everyone in that new data set I created. And then one step I do down here at the end. Say I try to create a REST API endpoint out of Microsoft Azure Machine Learning. So Microsoft Fabric doesn't have this functionality yet to be able to just deploy your models as an API, but Azure's machine learning service does. So I use this code and tried to do it. Something not quite right about it. I know that it can be done, but what we will do is run this code successfully, and then I will show you how to deploy this through Azure Machine Learning. So know that this exists. You can use libraries to deploy your registered models that you register with MLflow. But we're going to go the route of uploading it and deploying it that way. Okay, so we'll go ahead and run all of this. This will all end up working okay with a little bit of cleanup. You'll save the final machine learning models, and I can go in and look at it and choose which one I want. So I've run this before, so I'll actually go ahead and do that. So if you go to your workspace, you will see your experiments, and then you can select a model and create a model. So what your experiment looks like. Loading my experiment. Okay, so these are different runs I've done. I've did one starting yesterday and 3 of them today. You can look through each one of these, see which ones have the best results. And then we saw the ML model. You can click one of these and save as ML model. Whichever one you like the most. You can create a new one or select an existing one and replace the model. Say you're updating this with new data. You get different results. You could replace an old model with a new model. So I went ahead and already saved this in the data lake as and take 1 second. It's 1 minute to load, connection slow. We'll hit reload on this. Still just taking a minute. So here, this is back in the data lake. We want to, in one lake, we want to go back to our entire data lake. So if we can there, that's a little bit faster to get back to it that way. So the model that I saved is this TS coin history, ETH, ODSA. So time series, coin history, ETH, ODSA. That's the model I selected and saved. So note the original code, it's saved results, prediction results in the data lake. You can see that. Predictions. You can query this. Or load it into PySpark frame, data frame. We want to see the predicted labels. We'll just go ahead and run that. That loads it directly into PySpark frame. It doesn't seem to have worked the way we expected. So we'll just go back to the Lakehouse and query it from there, the SQL Analytics endpoint. Okay. Loading now. Just showing you that it did deploy to a table. And then using that, you can connect Power BI to that table to view predictions, or connect tables in a number of ways. You could later get actual data and see how it did against your predictions, or visualizing it, future predictions also. So making sure your model does what you expect. So I'm going to change connection here. This one's awfully slow. Back 1 second. And I'm back, hopefully with faster connection. Okay, so we have SQL endpoint. Go back. We actually want to see these tables that are in the Lakehouse. DE, first and last name, ODSA. It showed me my tables. You can see the predictions that it makes. And before I left, you can right click and select top 100. And before I left, said you could open it in Excel. You can explore the data to visualize the results. You can visualize it. Select the text of one of the select statements in your query and try again. You can load this query into Power BI or connect to that directly to visualize the deployed results. And then you could create a pipeline to continue to refresh the results and make new predictions and see them in Power BI. So the last step we want to do here is deploy this model. I'll show you how to do this. Like I said, there was code that you could do it through a Spark notebook. There's also another way. That allows you to create and test the endpoint also. So we'll go ahead and go to our model that we saved. Go back to workspace. Engineering workspace. Okay. So the model that we saved. And what we want to do is export this out of Fabric and into Azure Machine Learning Lab. So you can download the model, any one of these. I've already done that. In my downloads folder. I'll find it. Gives you a zip file, and I extracted the zip file with its own descriptive name. And then it gives you some files that you'll need to upload and recognize this model along with the code. So we can take this and then move it to Azure Machine Learning. So if we type in azure.microsoft.com, I've already set this up within Microsoft Azure. Sign in. Actually, we portal.azure.com. Take you to your Microsoft Azure portal. We didn't cover this in class, but I can show anybody who wants to set this up their account to be able to do that. And I could give you access to this service also. That's okay with me. So a workspace in Fabric. They have resource groups in Azure. I've created a, should be in here, Fabric. ODSA App Insights. I'm not sure where that machine learning lab went to. Let's see, storage account, the data lake and everything else we need. Let's see if there's any services we've used recently. Resource group. And I can't seem to find it, so we'll go create a new resource, machine learning resource. Then we'll connect it to all these things we need to connect it to. You can go to the marketplace to set it up. Type in learning and do Azure services only. Azure machine learning. So we'll create that. Okay. Create this as a resource in Azure. Okay, so we'll create in that resource group. We'll give it the name. Lab. And we already have these key vaults and application insights and everything we need. Don't really, it can do all the other default settings. That's fine. Take just a minute to create this. Okay, deployment in progress. We're going to see how this works. Okay, deployment, it'll take just a minute, few minutes. It'll let you know when it's done, it's completed. Go to that resource, then launch Studio. Okay. So it has a similar look to data science within Microsoft Fabric, but we're going to have some more features and the ability to directly deploy a model as a REST API. And this won't be required for the class project, but if you want to do this, that would be just fine. It's a way that you deploy these models. So if you go into notebooks or model catalog, we want to import that model that we downloaded. There's a lot of existing models that you could choose. Maybe that's not the place I actually want to go. So we'll go to model list. So we could go to model list and then register a model. It's an MLflow model is what we're using. We'll browse to where we downloaded it. We trust the site, sure. Okay. Name, we'll call it Fabric ML or DS Machine Learning or Forecast ML Forecast ETH price. We'll just call it that. Okay, upload model. Seems to be successful. Now we have some more options here. We've uploaded this model. You can see that there's now an option that's not available in Fabric. You can deploy this as a real-time endpoint. You have a couple options. Batch would be a bunch of observations at once for time. And then you could do it as using a different framework also. So we're going to go ahead and deploy real-time endpoint. Okay, so some of the settings here, you choose what type of virtual machine you want to run it on. We really just want to run it on the cheapest one possible. Okay. Endpoint name, it'll set that up for us, deployment name here. So that when you're in Microsoft Azure, there's just a lot more to configure. But I do guide you through all the things that you need to set up. So right now it's working on deploying it, and once it's successfully deployed, we'll test the endpoint. You could set up some monitoring for it also. We won't, we'll just test it to make sure it works. It'll take just a few minutes to do that. Okay, endpoint was deployed. Go here to endpoints. We can see that the name of that new endpoint that was deployed, which is great. It really takes a lot of the setup out for us. Having to set up a server and code and configuration to deploy REST API. Say we have a URL for REST endpoints. Around here, we can test this endpoint. So look for that option. We'll select this model, part of the deployment. That's it. Maybe that's it. Nope. I have traffic. Let's see. If we go to, we'll click through these around here somewhere. That option exists, endpoints. And perhaps it's one of the options in here. You could take a look at the logs. Here, we'll get this real quick. Somewhere in here there is it. To make sure it works. You could always write your own request to do it, but there's a testing option in here somewhere, and that's not going to help me out too much. And you have a lot of the same options you do in the other one, just or in Fabric, just more of these. We need to do just a little bit more. We don't have any serverless endpoints. Monitoring. You could monitor. Go back to endpoints. Struggling to find this. I guess we could just query it ourselves just to see if we could do it successfully. What happens if we just put this by the browser? Sometimes that works. Can't be reached that way. We don't need to update traffic. Oh, it's still creating it. That's why. It should, once this is created, give us an option to test it. Let's take another few minutes. It's taking another few minutes. Just want to conclude with showing you how this works. Still in progress. We'll wait. Sometimes it just takes a while for these things to work. Still working on it. Still creating. You just take a few minutes. I could pause the live stream. Don't believe I can without ending it. Still live stream. Nope, failed. Let's see if there's a reason why it failed. Give us that in the notifications. Doesn't seem to give us very much as far as details are concerned. So go back to endpoints. Well, this will take some work, but you could take my word for it that once you deploy this, you can test the endpoint using Machine Learning Studio. Okay, so that's it for this building model, Fabric. Building a model in Fabric using Fabric Data Science and deploying the model to a table, which you do in a Delta table within Microsoft Fabric. And you could also do this a number of ways, deploying it by REST API. You could create your own code and server. You could do it through Microsoft Functions or Microsoft DevOps platform, where you can do it through Machine Learning Studio generally. A few different ways to do it. Just wanted to show you how it'd be possible. So that's it for this demo.